Alright guys, so we're going to draw up this 1.5 inch compressor pin, and then we're going to do the cam toolpaths. So the main thing you want to look at is the overall length, which is 5.75, and 1.5 inch diameter. That's the largest diameter. That gives us a good starting point. What we're going to do is we're going to draw it up and use the revolve tool. Now this part, it can easily be drawn up by drawing a circle and then extruding that out and then drawing up another circle. So like this 1.5 inch, you could draw a 1.5 inch circle and extrude it out to 2.71, and then draw a circle on top of that and extrude that out 1.66. But what we're going to do this time is we're actually going to use the revolve tool. Okay, when you start doing lathe parts, it's a good idea to use the revolve tool because you can easily go in and make changes. Okay, so 5.75 long and 1.5 inch diameter. So what I'm going to do is I'm going to start off by creating a sketch. And because it's a lathe part, I'm going to select my front plane. And I'm going to draw a rectangle. Alright, so because we're going to use the revolve tool, what we're going to do is we're going to draw the cross section, okay, the turning profile. So it's actually going to be 1.5 divided by 2. Alright, so we're drawing the radius of it. And the overall length, that will stay the same, 5.75. Alright, so we have something that looks like this. Now, we'll go ahead and start off drawing the nose. It's 1.66 long and 1 inch diameter. So what I'm going to do is I'm going to select this bottom line. I always like to utilize the center line and just kind of copy and paste it up. Okay, so I'm going to go Control C, Control V, or you can also right click and copy. And it has a 1 inch diameter, so I'm going to pull it up half of that, a half inch. And it goes back 1.66. So I'm going to utilize this line, Control C, Control V. So I'm going to copy and paste it. And we'll make this minus 1.66. And I'm going to, on my keyboard, I'm going to hit T for trim, or I could just click the trim icon, the scissors. And I'm going to trim this up. Just like so. Okay, so we'll go ahead and start on the other side. So this nose is a half inch long and 0.75 inch diameter. So I'm going to select my center line. And it's a 0.75 diameter. So I'm going to go 0.75 divided by 2. Hit enter. And I'm going to use this line. And it goes back a half inch. So we'll just pull this up a half inch. Now before I trim it, I'm going to go ahead and use this line again because I don't want to trim it because then it makes things, it adds an extra step. Okay, so this diameter is 1.25 and it goes back 0.88. So I'm going to select this line, Control C, Control V. And it's 1.25 diameter, so I'm going to use this line. And I'm going to come up 1.25 divided by 2. Alright, so now I'm going to go ahead and trim. So I'm going to trim this up. And go ahead and trim this up. And I really don't need these center lines right here, so I'll go ahead and get rid of those. Everything looks good. Double check myself. Cool. Alright, so let's go ahead and save it. So this is the 1.5 inch compressor pin. Okay, so now we're going to revolve it. So I'm going to go here to my solid toolbar, and I'm going to use this third icon, the revolve tool. Alright, so I already selected the plane. I can clear that out so I can show you. Alright, so always make sure that you have a closed profile right here. If there's like a little gap or it's kind of double geometry, it can give you trouble. Alright, so I selected my plane. Now I need to select the axis. I'm going to select this as my axis. And I have something that looks like this. Okay, so we have a 50 thousandths chamfer, typical. So we'll go ahead and draw that up. So I'm going to go to Modify, Chamfer, and I'm going to select each one of these edges here. Alright, so we'll make this 0.05. Should look something like that. Alright, so we're going to do these flats. So the main thing you want to look at is from flat to flat, it's 1 1/4. And it goes 1 inch deep, okay? So what I'm going to do is I'm going to create a new sketch plane, and I'm going to select this face as my sketch plane. And there's more than one way to do this, but what I like to do is I just like to draw a couple of rectangles. It doesn't really matter what the size is as long as it reaches across this diameter right here. So I'm going to draw one there and one right here. Alright, so I'm going to hit escape to exit out of the rectangle tool, and I'm going to use the dimension tool. So we're going to dimension this and this and make it 1.25. And now if you look, this rectangle is covering more of this diameter than this one, right? I need to center it up, okay? So I'm going to constrain this to the center, and I'm going to make it 1.25 divided by 2. So now these two rectangles are centered. Alright, so now I'm going to use these rectangles as a tool to cut the flats on the part. Alright, so I'm going to go to solid and extrude, or I can just hit E on my keyboard, and I'm going to select these rectangles. Make sure you get these little faces right here. Alright, so I'm going to rotate the model a little bit so I can see kind of an angle view. I'm going to pull this back an inch. So you go minus 1 inch. Alright. If you're new at this, make sure your operation is uncut. If you're pulling it through the body, it should toggle the cut. But I don't know. If you're not used to using the software, just double check, make sure you have it uncut. So I'm going to hit OK. And now I got my two flats right here. Go ahead and hit save. Okay, so now we're going to switch to manufacturing mode, and we're going to create some lathe toolpaths on this. Alright, so first thing I'm going to do is I'm going to go to setup and define my stock and orientation. Operation type, by default it should be milling. Operation type, I'm going to put on, go ahead and put on select Z axis, plane, and X axis. And I'm going to, the Z axis, I'm going to click here, and I'm going to click my face. And I like to put this in front view and zoom in. You want your origin on the face of the part. You don't have to do it that way. It just makes the code a lot cleaner. So if you have to edit any G code on the machine, or if you're watching your distance to go during the setup process, it makes things a lot simpler. So I wouldn't put the origin on. Put the origin on model. You know what? I lied to you guys. Operation type should be turning. There we go. Okay, origin. We're gonna put it on model front. Okay. Now notice the red arrow is pointing down. That doesn't really matter because we're in a 3D workspace and everything's relative. You could pretty much just rotate this up because you're working with a revolving workpiece in a lathe. As long as your X, well, as long as your Z is on the face, and your X and Y, the origin is basically like in the center of the part, the center of rotation, you're good. So, I mean, you could rotate the part like this, create your toolpaths, or you could rotate it like this. It doesn't really matter. It's all relative. As long as the origin is in the center and the Z is on the model front. I'll go ahead and rotate that up just because I want to. Alright. So if we look at our part, we're going to say our stock material is 1.5 inch by 6 inches. Okay, so what I'm going to do is on this stock tab right here, stock diameter 1.5 is good. Make sure it's on fixed size cylinder, and we'll do it 6 inches. Alright, so I'm going to go ahead and hit OK. And it looks like my browser window moved. Let's see. I'll just put that right there. Okay, so I'm going to name this Op1. And I'm going to start off with a facing toolpath. So I'm going to go right here to turning face. I'm going to select the tool. If you don't already have a face tool, just go to your Fusion 360 library and put your tool category filter on. Put it on turning. And we'll use a turning general tool. Now these are in millimeter, but that's fine. What we'll have to do Okay, you know what? Let's just create a tool. Alright, so I'm gonna click a file. So you can make a tool. Either you can make like a local library, or you can save it to the file. We'll just save it to the file. So 1.5 inch compressor pin. So I have this file selected, right? So I'm gonna go up to this plus right here, and it gives me different tools I can create. So I'm gonna create a turning general tool. So go ahead and select that, and we'll just name this We'll name it face and OD tool. And we'll make it a tool nose radius of 0.015. Okay, so what I'm going to do, our shape, we'll have it 80 degrees. What we want to change is this corner radius. We'll make it 15 thousandths. Okay, so by default, all this should be good. Surface feed. I mean, ideally, usually what you'll do is you'll just take a look at the inserts you're using and get the surface speed off of that. We'll just put this at 950. Feed rate, put it at 12 thousandths. I like to make my cutting feed rate and my lead in and lead out the same feed rate because it's easier to do edits on the machine. And tool number 1 is fine, so we'll hit accept. Okay, so first thing we'll do is we'll change our maximum RPM. You always want to have as a safe speed. Pretty much the larger the part, or the larger the diameter, or the further the stick out from the chuck, you'd want to go slower. Okay, and we'll put this at 1800. Okay, so a lot of this stuff we can really go without changing. We have an 1/8 inch to face off of his front, so we'll put this on multiple passes and we'll make it 50 thousandths. And we're going to keep this simple today. We won't worry about a finish pass. We'll just make it, it'll just rough, it'll just face it to Z0. Alright, so we have something that looks like that. Rename this. If you click on your toolpaths, you can just rename it. It was already named face 1. I just didn't like that 1 in front of it. Okay, so that's our face right there. Now we're going to turn the OD. So I'm going to go right here, turning profile roughing. I'm going to use the same tool. I'm going to change my maximum speed to, we'll say 1800. We'll start the model front, and we're going to turn back to where this chamfer ends. Okay, so we're not going to turn back to this face. Now this diameter right here is already on size, so we don't have to cut that. But we want to put a chamfer here. So on the back mode, we're going to put this on selection, and right here where it says back reference, we'll click this, and we'll click where this chamfer ends right here. And if I put this on side view, you can see it ends right there. Alright, so we'll just hit OK. This is the toolpath it gave us. These little blue lines right here, that's where it leads out. So it's gonna turn back. Yeah, hold on, let's simulate this. Yeah, the blue line is where it leads out. It leads out at 45 degree. I'm not too crazy about the 45 degree lead out. I mean, it works pretty good. It actually helps with tool life. It's just, it makes your G-code files longer. And if you need to edit code at the machine, it makes things a little bit more complicated. Okay, so that looked good. Let's go ahead and change our depth of cut on there. So I'm gonna change, go to passes, and we won't leave anything for stock to finish. We're going to keep it simple today on this part. If you want to have a really nice smooth finish, and I mean, if we were going to make this for a customer, we would do a profile roughing and save, you know, like 10 thousandths for finish, and then come do a turning profile finishing. But we're only going 12 thousandths feet rate. That'd be fine. Depth of cut, go 50 thousandths. And okay. Okay, save. And we'll simulate this. Alright, looks good. Okay, so that's the first operation. Now the second operation, we're pretty much just going to flip the part over and do the same thing on the other side. Now, we could go create another setup and then go make another face operation and another turning operation. Since we're using the same cutting processes, the same toolpaths, what we could do is actually just right click on the operation 1 and go to duplicate, and we'll check that. We'll hide this op1, we don't need that no more. And what we'll do, let's rename this. Yeah, I'm just clicking on it twice slow, and it'll highlight it, let me rename it. Okay, so what we're gonna do is edit, because we gotta change our orientation. We want our Z0 on this face now, right? So I'm gonna go to Z, click here, and looks good. Hit enter. Now you see we got these alarms right here. That's because we need to reselect our starting point, because the Z switched over to the second side. What we'll have to do is basically reselect the geometry that's cutting. So if you look, the front is over here, so we need to reselect that. So alright, notice it's not really changing, huh? Let's hit cancel. Let's make sure we have everything. Alright. Okay, so let's go to edit. Okay, it didn't actually switch over. Oops. Okay, so we're gonna check this box that says flip Z-axis. Now we should be fine. And if you want to, you can rotate the model so the X is pointing up. It doesn't really matter, but it looks nicer on the video. Okay, so everything's fine on that, so I'm gonna hit enter. Now I'm gonna go over here and edit this, and as you can see, it already updated. I could literally just hit OK, and the profile roughing, we'll go to edit, and we'll go to our geometry tab here. Okay, so it still has the selected back reference from the first op, so we're gonna hit this X to clear that out, and we're gonna reselect it. We're gonna click on back reference, and we're gonna turn to where this chamfer ends right here. So hit OK, and that's our second op right there. Alright, so I actually like to rename these OD turn. And I'm going to do the first stop the same way. Okay, so we get our first two operations. So the part's almost done. We got to cut these flats on here. So you could face this off, but then you would have to rotate the part, which would require either a super spacer, index of chuck or super spacer, or 4 axis on the mill, or depending on the application of the part. Now this flat right here, usually flats like this is either for fastening, so you can lock it down with like a set screw, the mating parts that attach to this, or it's to put a wrench on. Okay, now because that's what the flat's most likely for. I mean, obviously you want to get information on what the application of the part is, but because of that, you could run it like this and just drop it in mill on each side. And now it would have a radius right here, but that's what you could do. Alright, so I'm going to close these two ops up right here, and we're going to go to setup, and this time we're going to do milling. Okay, so let's go to our stock. We'll make it relative size cylinder, and our axis would be this OD. Oh, it could be any of these ODs. Alright, radial stock offset, we'll put that at 0. Now, depending on what the part's for, I mean, if you're going to run a bunch of these and you wanted everything to be spot on, you would probably want to invest the time in actually making a solid file and importing it in and actually using that. So, basically you can set that up as your stock, and it would be what the stock would look like, the shape and the size of the stock after the lathe operations. But most time, simple little parts like this is really not worth the time. So we'll just put it on relative size cylinder and put this at 0. Okay, so we're gonna say, we're going to think about where we're going to set our tools. You probably set your tools on top of the stock, and you'd set your X and Y 0. Basically, the Y would be at the center of the cylinder, and X would be on the edge. So what I would do is I would put my origin right here. So it looks something like this. And that's because you're going to use the edge finder to get your X and Y 0. Because the part's symmetrical and round, the Y would be in the center and the X would be on the edge. And because you're setting your tools on top of the part, your Z is going to be right here. So I'm going to hit OK, and I'm going to rename this mill op, or you can name it op3. I mean, you can name it whatever you want. Just you want to name it something that, if your coworker is going to open the file, he's going to know what's what. Okay, so have the stock set up, and we'll use a 1/2 inch end mill to cut these sides. So we're on milling. We'll use a 2D contour. So we're gonna create a tool. So I'm going to select the file that the tool's going to be saved to, which is the 1.5 inch compressor pin. And I'm going to go to plus. I'm going to go to flat end mill. We'll name this 1/2 inch end mill cutter. We can leave everything default except the diameter. Make it a 1/2 inch. Cutting data, we'll go 2200 RPM, and we'll cut at 20 inches a minute. Ramp, we'll keep that at 20. Plunge feed rate, put it at 30. Tool number, it's gonna be a different machine. We'll just put it at tool number 1. I'm gonna hit accept, and I'm gonna go over here to select. Okay, so if you notice, all my speeds and feeds auto filled into the settings here. So I'm gonna go to my geometry tab, and we'll select the contour. So I'm gonna select. So I'm gonna click contour selection. I'm gonna click. All right. So notice it's wanting to select this whole chain right here, right? I only want to select just this one line. So what I'm gonna do is I'm gonna hold my Alt key down, and it'll allow me to select just that line, right? Let's see, and it'll also let me select. You know what? We'll go ahead and do this. All right. So if you click these red arrows, you can switch sides, and you want to be on the outside of the part. Okay. So like this right here, this would cut into the part. Okay, because you gotta think. It's a 1/2 inch end mill, right? So the toolpath is going to be driven off of these segments, and the software needs to know which side of the segment you want the diameter end mill to compensate for. Okay, so the software is going to compensate for the diameter on this side. You don't want to go in here because it's going to drop down a 1/2 inch, and you're going to have a broken end mill. Okay, so I have that. Our height tab. Alright, so what I'm going to do is I'm just going to change this bottom height to model bottom, and so the only thing we really have to think about is how deep do we want the end mill to cut, right? So the flat actually ends right here. You could do the math and get like an exact calculation, but you're gonna need to go a little bit deeper anyways, just to compensate for any kind of radius that's on the end mill. So, you know, a little bit lower than where this flat ends is probably good. And the clearance type and retract type, I'll always put these at 0.1. It's just personal preference. Really, the only thing that really matters is, you know, make sure you go deep enough. Alright, so just to show you what toolpath it gives us without changing these settings yet, I'm just going to hit OK. Alright, so it didn't give us a toolpath at all. Alright, so let's check this out. So I'm going to click on this error. The contour was not machined because given the lead-in parameters would cause a collision. Okay, so what that is I'm going to go to Edit. So we're going to go into this 2D contour toolpath. Your lead-in and lead-out is on the linking tab right here. So what's probably going on is a sweep angle is at 90. I'm gonna put that at 0, and let's just hit OK to see what it does. Okay, so it actually doesn't like this. Now, these arrows being at different heights doesn't matter because our height is driven from the information on this tab right here. What's probably going on is the software isn't too sure about our stock. Just for the fun of it, I'm going to change it to conventional milling. I want to see if that changes anything. Oh, it did. Okay, so this is what's going on. See how it looks funny? That's because the stock, the way I had the stock set up, the part looks like this. Now, we already turned it on the lathe, right? But the mill op, it thinks the stock's right here. So basically, when we simulate this, it thinks that it's kind of diving into the stock right here, which is really not. Also, we don't want the tool to just stop right there either. So what we'll do is, alright, so it's feeding to the left, in conventional mode. So we could do a number of things. We could change our lead in. And lead out. Let's see. I don't know why it's not picking up that lead out. Here, let's make it a 1/2 inch. Okay, so it should be leading out away from that flat, but it doesn't like it. So it feeds in, hold on. It's leading out vertically. Why is it doing that? Alright, so we'll uncheck this where the lead in and lead out's the same. And let's just see, okay, let's just see what kind of toolpath it gives us. Okay, I see what's going on. So right here, there isn't enough material left for it to lead out. So it can't get all the way to this corner and then lift up or off to the side. So it's just calling it done. Now there's different ways around this. I mean, one thing we could do is we could switch back to design mode and actually draw a line right there. I want to try to get it in these settings, in the parameters here. Okay, so we got our lead in, and lead out. Okay, so I'm going to show you a little trick. Let's go ahead and save. So one thing we could do is we can do this the old school way. And we'll create a sketch here. Alright, so let's see if it lets me touch on that. Alright, so Alright, so this is 1.5 inch diameter and it's 1 1/4 from flat to flat. What I'm going to do, if I hover my cursor over the origin and come up, it'll reference off that, right? So I'll be lined up with that face. And I'm just going to extend it out, but I want to make sure I'm at 180 degrees, which I am. Let's go ahead and lock that in. Alright, and I'm hitting tab on my keyboard to toggle between dimensions here. Alright, so 2.8 is not the right dimension, but we're going to leave it at that for right now. Alright, so what I'm going to do is we have 1.66 and it's going back at inch, right? So we'll make that line stretch over 2.66, right? So I'm going to go to dimension. We'll make this, okay. It's already dimension. Let's see. I'm just going to double click that existing dimension, make it 2.66. Alright. And we'll dimension it from the center. So from flat to flat, it's 1 1/4. So we'll go 1.25 divided by 2. And we get that. Hit escape to exit dimension mode. And we'll draw another line. So I'm going to reference off this. And I'm just eyeballing it. What I'm making sure is I'm off of this Z0 right here. Alright. Alright, so I'm just going to enter 2.66. That's where the flat ends. And we still have to dimension this vertically. So go 1.25 divided by 2. Okay, so we have that. And it's 1.66 from here. Let's do this. So we're gonna use a 1/2 inch end mill. So let's just go up. Let's see. We'll go up 0.35. Escape. And I'm going to draw another line, connect it down here, and we'll make that 0.35. And just make sure it's at 90 degrees right here. Alright. Now this line doesn't really have to go across right here. So what we'll do is we'll draw a vertical line and dimension this. Alright, so this diameter goes back 1.66, right? So we could type in 1.66 minus 0.35. Alright, I'm just going with 0.35 because my math is based off the radius value plus some extra I just rounded up. So it's a 1/2 inch in mill we're going to use. So the radius of that is 1/4 inch. So I need the center of the end mill to travel, you know, to start in front of the part, you know, in front of the cut. So 0.2, you know, it's got to be at least 0.25. So I'm just adding extra 100 thousandths to it. That's how I'm basing my math off this. Okay, so I'm gonna hit T for trim, T on my keyboard, and I'm gonna trim this up, this. Go ahead, trim. That should work. All right. We'll go ahead and finish sketch and save it. All right, so we can always come back and hide these when we're through. We're just gonna keep them visible for now. Okay, so basically I outlined the cut, right? Now notice they're in the center of the part. It doesn't really matter the height because our height's gonna be driven off of the height tab. All right, so I'll go to edit. We'll go to our geometry. We'll clear out what we had, and now we're gonna select this. All right. We'll make sure we're on the right side of the line. Oops. I'll select that right there. Alright, so this one is on the wrong side. You know, it needs to be on the other side, so I'll just click that red arrow. Looks good. Let's hit OK. Looks fine. Now remember, our stock is already turned down from this lathe operation, right? So when we simulate it, all of this is going to be cut down. Now if you wanted to, wrong side. Now if you wanted to, you could draw your stock up. But I mean, this is fine. It really depends how many parts you're running, you know. If there's enough money in the job, or if it's worth it, draw the stock up. It only takes like an extra 5 minutes. Actually I have a shortcut for that too, but that's another video. But anyways, so this material is going to be gone right here, so just keep that in mind when you watch this mill op. So it looks kind of funny on the simulator because it shows the stock being cut here, but that doesn't really matter. Alright, so come in, cut that, and we're good. Now you may want to take 2 passes here. That it probably cut. Let's see. It probably wouldn't cut super good. Like you might get a little chatter or deflection on the end mill. So what I would do is on the passes tab, we'll take a rough pass. We'll just put it on rough pass. You can leave out 1. It's gonna, even though it's on 1, it's gonna take a second one for the finish. Or it's gonna be 1 rough pass. And then it'll be the pass to the contour, selected geometry. Alright, so we'll simulate it. Now you could only do this on this part if you get the okay to make sure that, you know, the customer don't care, but there's a big radius right there. Now usually on a part like this, that flat's just to lock it down to this kind of bushing or something, or it's to put a wrench on so you can turn it or whatever. Okay, so because of that context, you know, the application of the part, a radius right here wouldn't really matter. And if you wanted to, you could go a little bit deeper too. You know, it depends on your tolerance, depends on the customer, but that's it. That's the part right there. And you could go to each one of these operations individually and go to post process. Don't do them all at the same time, because first off, this is a mill op and these are lathe ops. But like this mill op, I'm going to, well, I'll put this on milling. Vendor, I'll go to Haas, and I have these post processors. I can use this pre-NGC. Name it flats, and let's see. I need to update this my laptop here. The new version of this update that we did on this version of Fusion. If you use the same program number, it doesn't override it. It'll actually pull up the old program. But anyways, so here's my flats here. There's a G code, and if I wanted to post process, I want the G code for OP1. You know, I'd put this on Haas turning and give it a program number or something, you know. And this would be my G code for the first Lathe. Well, why is it doing that? So this is what I'm talking about right here. I need to update this version of Fusion, but on some of the older versions, for a little while there, they had it doing something weird where when you post process it, if you didn't change this program number, it would actually pull up the program that was named that instead of actually posting the code that you wanted. But anyways, so you just right click on each one of these operations individually and post process it, you know. So you'd have a G code file for OP1, a G code file for OP2, and a G code file for the mill op, and that's pretty much it.